Okay, hi guys. So here's a couple examples using accumulation functions. So here's the first example. We've got this graph of m, and we're given this accumulation function h of x equals the integral from -2 to x of m of w dw. And guys, I want to just talk about something real quick. So for J4, which was the last lesson, we had like these accumulation functions, and then we had like the graph of the input of the accumulation function off to the side. And then we were asked questions about when G was increasing or decreasing. And guys, what we should have seen from J4 is that this function J is increasing when this input function is positive, and this function G is decreasing when the input function here is negative. And guys, that should remind you of something. This should remind you of Susan's table. And normally in Susan's table, when we had like, increasing, decreasing, and then the next column, positive, negative, it's because this here was the derivative of that. And guys, that is actually the case with accumulation functions, okay? So it turns out that the input of the integral on the accumulation function, that is the derivative of the accumulation function. Okay, so here we've got this. If g of x is the integral from a to x of f of w dw, then g prime of x is equal to f of x, okay? So the input here is the derivative of the entire thing. So we're going to do a couple examples. For this one, over which intervals is h increasing, explain. At which value or values does h have local maximums or minimums? So the first thing you've got to do is take a look at this accumulation function and recognize that the graph of m here, that's actually h prime. So over which intervals is h increasing? All right, so we're going to take a look at that. So this is like h, so this is like h, and then that's like h prime. So h is going to be increasing when h prime is positive. And h prime is, so h prime of x, and h prime is the same as m. All right, so I'm going to state my answer, and then I'll show you how to explain it. So the answer is going to be from 4 to 12. And you're going to start off, they did not tell you this was the graph of h prime. You have to make that connection. So the first thing I'm going to say is because m of x is h prime of x, so h is increasing when m of x is positive. All right, so you have to tell them that you know you're looking at the derivative and then therefore what that implies. All right, now for B, at which values does h have local maxes or mins? So, all right, so h prime, all right, this was a little chart we had. We had critical numbers, max, min. All right, so critical numbers were when the derivative was 0 or undefined. Max, positive, negative. All right, that was one of our charts that we would write all the time. So for a max, I'm looking for this kind of sign change on my graph. For a min, I'm looking for that kind of sign change. So my answer, I'll have a min at x equals 4, and then I have a max at x equals 12. And then I'll say because, again, m of x is h prime of x, so h has a max when M changes from positive to negative, and a min when M changes from negative to positive. Okay, now let's do this. So we got this graph of Q, and we have K of X is the integral from 8 to X of Q of W dW. So first observation is that Q is K prime of X. Right, that's the first observation. Over which intervals is K concave up or concave down? Explain. At which values does K have points of inflection? Okay, so I look at this. Oh, no, I'll look at this. All right, so let me extend this table. So increasing, decreasing, extrema, concave up, concave down, point of inflection. I'm just completing Susan's table. All right, here we'd have a sign change, concave up, increasing, decreasing, extrema. Okay, so for concave down, I'm looking for the derivative graph to be decreasing. For point of inflection, I'm looking for the derivative graph to have an extrema. All right, so for part A, for which intervals is K concave down? So it's going to be from 9 to 14, union 17 to infinity, because Q of X is K prime of X. So K is concave down. I should write it. So K is concave down when Q of X is decreasing. All right, and then for part B, at which value or values does K have points of inflection? So extreme is at 9, 14, and 17. At X equals 9, 14, and 17, because Q of X is K prime of X. So K has points of inflection where Q has extrema.